Howdy, my name is Natalie Chavez.
And my name is Hannah Garcia.
And today we'll be presenting Project 6 Immunological Tolerance, Autoimmunity, and Hypersensitivity Summary. Immune System's Unresponsiveness to Self-Antigens Tolerance Overview. Immunological tolerance is when lymphocytes do not respond to antigens through exposure to these antigens. Usually antigens named immunogens activate lymphocytes to proliferate and differentiate into other effector cells or memory cells, so a productive immune response can be generated. However, some antigens, known as tolerogens, cause lymphocytes to become functionally inactivated or even killed, leading to tolerance. These two main types of tolerance characterized by which organs and lymphatic systems they take place in. Central tolerance takes place in the generative lymphoid organs, either the thymus for T cells or bone marrow for B cells. During central tolerance, immature self-antigen specific lymphocytes encounter self-antigens and may be either deleted or apoptosed or functionally inactivated. In addition, B cells may engage in receptor editing or changing their specificity, and T cells may develop into regulatory T cells. Peripheral tolerance, while slightly similar to central tolerance, takes place in peripheral lymphoid organs, such as lymph nodes. Their lymphocytes may become functionally inactivated, deleted, or suppressed by differentiated regulatory T cells. Each type of lymphocyte also experiences its own version of either central or peripheral tolerance. Moving on to immune system's unresponsiveness to self-antigens, T cell tolerance, and peripheral tolerance. Central T cell tolerance is characterized by either deletion via apoptosis or development into regulatory T cells. Some immature T cells may exhibit a strong interaction with self-antigens presented to them by self-MHC, receiving signals that trigger their cell death via apoptosis. Other lymphocytes recognize these self-antigens, but rather than die, they develop into regulatory T cells, which are capable of suppressing immune responses by lymphocytes. During peripheral tolerance in peripheral lymphoid tissues. During peripheral T cell tolerance, T cells may undergo either anergy, functional unresponsiveness, suppression by regulatory T cells, which block inactivation, or deletion, other known as apoptosis. Central B cell tolerance has three main components: receptor editing, deletion, or anergy, functional unresponsiveness. Receptor editing involves immature B cells experiencing re-expression of the RAG genes, resuming gene recombination in their light chains, resulting in new Ig light chains. B cells can also experience apoptosis through death signals should receptor editing fail. Lastly, B cells may recognize such self-antigens as some soluble proteins with low avidity, resulting in the reduction of receptor expression and ultimately functional unresponsiveness. During peripheral B cell tolerance, B cells may experience either functional inactivation, death via apoptosis, or activation suppression via inhibitory receptors. Moving on to
Factors that lead to loss of tolerance and autoimmunity. Autoimmunity occurs when an immune response is developed against self-antigens. The opposite of immunologic tolerance, autoimmunity may be either organ-specific, in which it affects a few organs, or systemic, in which it causes injury to many tissues and may have many clinical manifestations. Lymphocytes against self-antigens may cause autoimmune tissue injury. Two factors which may contribute to autoimmunity development and eventual loss of self-tolerance are genetic susceptibility and environmental stimuli. Various genes conferring autoimmunity susceptibility may influence failure of self-tolerance, resulting in lymphocytes becoming self-tolerant. On the other hand, environmental stimuli such as infections and stimuli that cause inflammation may promote a lymphocyte influx into tissues and activate both APCs and self-reactive T cells, ultimately leading to tissue injury. Finally, hypersensitivity is a type of immune response which may cause abnormal tissue injury and disease. There are 4 different types of hypersensitivity reactions, each classified by their respective principal immunologic mechanisms. Type 1, or immediate hypersensitivity, is classified by mast cells releasing mediators. Type 2 hypersensitivity is when antibodies against cellular antigens damage cells or tissues, impairing their function. Type 3 hypersensitivity involves the formation of antibody-antigen complexes that deposit themselves in various tissues such as blood vessels, causing both tissue injury and inflammation. Lastly, during type 4 hypersensitivity, T cells, oftentimes against self-antigens, cause such diseases as multiple sclerosis, rheumatoid arthritis, type 1 diabetes, Crohn's disease, and viral hepatitis.
These are our references, and thank you.